Research project is on autism spectrum disorder. I'm mainly going to focus on the overgrowth, hypoconnectivity, and hyperconnectivity in the autistic brain and how that is actually relevant to behaviors seen in the disease. Autism spectrum disorder is a disease in which people are impaired in their abilities to make decisions, form emotions, and form relationships. An example of this is people with autism often can't make decisions where deductive reasoning, like weighing the benefits or the risks of a decision, are important, such as even something as small as brushing our teeth. When given the option, someone with autism spectrum disorder might not be able to realize that the reason they need to brush their teeth is so they do not have cavities and they do not have to go to the dentist. Autism actually affects about 1% of the population worldwide. That's about 77 million people that have been diagnosed with autism. And of these people, more are males rather than females. The cause of autism is unknown at this time. There have been scientific findings that point to a difference in connectivity in the brains of individuals with autism spectrum disorder when compared to that of the average brain. This finding is backed up by several studies that have used neuroimaging and MRIs to actually show differences in this connectivity. Differences in the brain of an autistic person versus the normal brain. That would be premature overgrowth in children with autism is the first thing they usually see across the lifespan, and that is where they actually have too much growth of their brain at an early age. So when compared to that of the average child, their brain is progressing too fast and growing too much, more than it actually needs to. So this difference usually levels out around the age of 6. Their brains are about the same size, and as the lifespan goes on, people with autism actually, you see a possible regression, but that's not actually been proven this far. There's also hypoconnectivity and hyperconnectivity in the brain of people with autism. And the hypoconnectivity is just things are not connected like they need to be. The crosstalk of the brain, if you will, from basically your hypothalamus to your frontal lobe and other areas is not as good as it needs to be or as good as it is in the average person. You also see hyperconnectivity in people with autism in places where there's too much connectivity. It's connected too well, which leads to overstimulation. Children with autism have been shown to have a 10% larger brain at the age of 2 to 5 years old than the average child. This is particularly interesting because at about the age of 3 is when children are diagnosed with autism, and that's when they're actually showing behaviors of autism spectrum disorder, such as their language abilities, their cognitive abilities, their ability to show emotion is not what it would be of the average child. And that's usually, it directly correlates, this overgrowth correlates with these specific behaviors, the timing of these behaviors. Development of the brain of people with autism differs from that of the average person in the frontal and temporal lobes. The main one I'm going to focus on is the frontal lobe, mainly because the frontal lobe is responsible for decision making and cognitive abilities, and it also contains the limbic system, which controls your emotions. So it controls also like your affect, like you showing emotions and your understanding of emotions, which is important. Overgrowth in autism is seen at 18 to 35 months as well. This is said in particular studies to lead to an abnormal connectivity of the brain in a person with autism. which directly correlates with the hypoconnectivity and hyperconnectivity and makes sense. Overgrowth in autism spectrum disorder is said to maybe be caused by early proliferation of radial unit progenitor cells, an increase in proliferation units, ontogenic columns, and then an increase in surface area. So this is the science that they think is behind the actual overgrowth in surface area in people with autism. Radial unit progenitor cells produce neurons and intermediate progenitor cells that produce neurons. This is important because if you have too many neurons, it can actually mess up the connectivity in your brain. And I'll get to that in a minute. So the early proliferation of progenitor cells might lead to increased neurons and synapses. Increased neurons lead to a worse connectivity. I'm going to use these pictures to kind of try and explain that. On the left side, you have what I see as regular connectivity. You've got a straight line from the hypothalamus to your frontal lobe. From each area, your message can't get misconstrued. It's in a straight line. There's nowhere else for it to go. However, on the right side, if you had too many neurons in your frontal lobe and you're trying to get this message across, if they run into too many neurons, it's like one person trying to pass a message to one person and then to 2 people, 3 people, 4 people. Obviously, the message is going to get misconstrued somewhere. And you've got all of these neurons that are sitting there and they're not doing anything. So this is just a crowded area in which messages could be completely misconstrued, which could actually lead to the hypoconnectivity in the frontal lobe. So this is just a slide to kind of explain the hypoconnectivity and hyperconnectivity. So hypoconnectivity obviously means low connectivity. Things are not working like we want them to. So on your left, you see this picture of 2 people with tin cans and string. Yes, the message is getting through, but over a long distance, the message could get misconstrued and could be misunderstood, and it would not work as well as like our middle picture, which would be regular connectivity. You know, you're talking back and forth, the message is understood. Also, on the right-hand side, I have an example of hyperconnectivity. Hyperconnectivity is high connectivity, but it's actually too much connectivity, such as if someone had a megaphone and was talking in your ear, it would be too much and overstimulation. So this is actually a diagram from a paper that was part of my research, and this diagram shows the brain, the autistic brain, when compared to that of a controlled brain, which would just be someone who does not have any deficits, you know, the average person. Blue lines show hypoconnectivity. Obviously, that's the one that is more prevalent in the autistic brain. And the red lines show hyperconnectivity. So the hyperconnectivity that we're going to talk about is going to be mainly, we're going to focus on the somatosensory, and we'll get to that here in a minute. It's proven that people with autism have hypoconnectivity in the frontal cortex. So this weakened connectivity could then theoretically lead to an impaired ability to make decisions and in goal-oriented behavior. So observed a young lady with autism spectrum disorder. She is about 20 years old. She's a Caucasian. And in watching her reactions and her decision-making, I noticed some correlations between this hypoconnectivity in the frontal cortex and some behaviors she exhibited. So, for example, growing up, she would be told not to do something because it was going to harm her. It was going to actually cause her harm. And, you know, as any parents do, they said, if you do this, you know, there's going to be a punishment of some sort. When being told this, she could not understand the danger in what she was doing, and she continued to do the behavior anyway. That behavior actually shows a correlation between this hypoconnectivity in the frontal lobe and her behaviors, the way that she lives her life. Hypoconnectivity in people with autism is also seen in the limbic system. The limbic system controls emotion, and it also contains the anterior cingulate cortex that controls affect and ability to comprehend emotions. So this hypoconnectivity would obviously, in theory, lead to deficits in socialization and ability to show emotion in people with autism. As I stated earlier with the young lady that I observed, she had a family member die. When this family member passed away, obviously most of us, when we lose someone, we cry or show some type of emotion, whether it's sadness or whatever. This person actually just stated that that person was in heaven and showed no emotion. And that's not to say that she has no emotions. Obviously, when she didn't understand something, which goes back to the cognitive ability, she would get angry. And she could show that well, but she just did not display the emotional attachment that the normal person would. Behavior obviously correlates with the hypoconnectivity in the limbic system, that obviously there is a hypoconnectivity here. Area of hyperconnectivity in autism that I want to focus on is the hyperconnectivity in the somatosensory. Somatosensory has to do with your sense of touch and your sense of hearing. So back to the young lady that I observed growing up, when she was being told to try different foods and eat different foods, there were certain textures that bothered her. And this would actually correlate with the hyperconnectivity, causing the person to be overstimulated when exposed to a particular sound or touch. Not stand the texture of potatoes, and still to this day cannot like mashed potatoes. Different textures that are alike. And also, when just talking about a simple hug, this person also did not like to be hugged very much. It was obviously an overstimulation for her. She did not like it and did not want that physical contact. So these behaviors obviously correlate with the hyperconnectivity seen in the somatosensory cortex in people with autism. After my research and observations made of the young lady that I stated earlier, the early brain enlargement, hypoconnectivity in the frontal lobe, and hypoconnectivity in the limbic system, hyperconnectivity in somatosensory could cause the behaviors indicative of autism, as seen by the behaviors that I have just told you. More research of people with autism could lead to the discovery of the cause of autism and the cause of this actual hyperconnectivity and hypoconnectivity that is so prevalent in people with autism, and hopefully one day they will find the cure of autism. And that's the end of my presentation.